Welcome to the class of Econometrics 2. My name is Yasser Saeed, and today our topic is vector autoregressive model. So here are the outlines of the lecture for today. We will try to understand the vector autoregressive model, and we will derive the basic equations that are required for the vector autoregressive models. And then our second objective for this lecture is that we will be discussing the advantages and disadvantages of vector autoregressive model. What is vector autoregressive model? In order to understand this, first we need to understand a very basic model of econometrics. We have two variables, one we call yt and the other we call xt. Now in normal models, what happens is that xt causes yt. Any changes in xt will result in changes in yt. But the reverse is usually not true in those models. Yt does not cause xt, meaning that yt is endogenous variable and xt is exogenous variable. In vector autoregressive model, there are no endogenous variables and no exogenous variables, but all variables are treated equally. That means that xt can cause yt, whereas yt can also cause xt. And not only that, but yt is also caused by yt minus 1. Yt minus 1 can affect the value of yt. Similarly, xt minus 1 can cause xt. And also yt minus 1 causes xt, xt minus 1 causes yt. So there are a lot of simultaneous equations created because of these interdependence. The variables all depend on one another. Therefore, Sim in 1980, he was the first one that criticize the original models. According to Sims, if there is simultaneity among a number of variables, then all these variables should be treated in the same way. In other words, there should be no distinction between endogenous and exogenous variables. Therefore, once this distinction is abandoned, all variables are treated as endogenous, means that all variables cause each other. Now what we want to do is to convert it into a model form. We have yt that depends on xt, yt minus 1 and xt minus 1. So how we convert it into a model form? We write the original yt, which is equal to beta 1 0 minus beta 1 2 our first variable, the xt, and then plus gamma 1 1 second variable, that is yt minus 1, and then plus gamma 1 2 xt minus 1 plus uyt. In a similar fashion, we also write this equation for xt, which depends on yt minus 1 and xt minus 1. So that equation can be written as xt is equal to beta 20 minus beta 21 yt plus gamma 21 yt minus 1 plus gamma 2 2 x t minus 1 plus u xt. So basically both these equations are identical, but one we have done for yt and the second one we have written it for xt. So this equation is true under two assumptions. The first assumption is that both yt and xt, they both are stationary. And the second assumption that the error term u yt and uxt, they are not correlated, and again they are random. So the model will only work under these two assumptions. Now this is our first order vector autoregressive model. Why we say that it is the first order vector autoregressive model? Because the maximum lag length that we have is t minus 1. If we use certain other variables like xt minus 2, xt minus 3, then the order of this vector autoregressive model will change. For example, if we are using independent variable up to t minus 3, then this will become a third order vector autoregressive model. Also, this model is not contemporaneous. This model is contemporaneous. It has contemporaneous effects. xt affects yt, but that effect is separate from the second equation where yt is affecting xt. Both these effects are separate. So the equation is basically not in its reduced form. We want to convert this model into a reduced form. For that purpose, we write the equation, and we will bring all the major variables, the xt and the yt, to the left hand side and let the other variables on the right hand side. So we write the equation yt minus beta 1 2 xt equals to beta 1 0 plus gamma 1 1 yt minus 1 plus gamma 1 2 x t minus 1 plus u yt. In the similar fashion, we write minus beta 2 1 yt, that is from this position we have shifted it to the left side, and then just write under xt, we write the equation of xt, that is simply xt with coefficient of 1 is equal to beta 2 0 plus gamma 2 1 y t minus 1 plus gamma 2 2 x t minus 1 plus uxt. So basically what we have done, we have aligned all the variables. Here we have yt, here we have below yt we have minus beta 2 1 yt, then again xt below xt, constant below constant, then yt minus 1 is aligned with yt minus 1, xt minus 1 is aligned with xt minus 1, and the error term is aligned with the error term of the second equation. This helps us convert the model into a matrix form, where first we write the coefficients of each variable. The coefficient of yt in the first equation is 1. Then in the second equation we have minus beta 1 2. Sorry, in the same equation, but for xt we have minus beta 1 2. In the second equation minus beta 2 1, and again the coefficient of xt is 1. This is multiplied by yt and xt, which is equal to the constant beta 10, beta 20, plus, again we do the same trick, write the coefficients first, gamma 21 and gamma 22 multiplied by the variables y t minus 1 and x t minus 1. So this matrix is basically using the lag variables, and again the last matrix, that is of the error term uyt and uxt. Now to make a short form of this matrix equation, we can give name to all of these matrices. The first matrix, that will become beta, the second zt, denoting that it is a matrix representing variable, again that is equal to gamma naught representing the constant, and gamma 1. For the next one we have z t minus 1, since it is exactly the same equation of z but with one lag, so z t minus 1, and then the last matrix represent the error, so we write it as ut. The short form, we have beta zt is equal to gamma naught plus gamma 1 z t minus 1 plus ut. Notice that it is almost like ordinary least square equation, but here we have one problem. We have beta on the left hand side, so we want this beta on the right hand side. So multiply both sides by inverse matrix of beta, that is beta raised to power minus 1. We will get zt rho beta minus 1 gamma naught plus gamma 1 z t minus 1 multiplied by beta minus 1 plus ut, and again multiplied by beta minus 1. So we have to rename these variables once again. We are left with zt, but now we name beta minus 1 gamma naught as a naught, then gamma 1 into beta minus 1 is simplified and we name it as a1 z t minus 1 plus, we rephrase this whole error term as et. So we get the reduced form of our equation for this model. So before ending this lecture, let us discuss some of the advantages and disadvantages of vector autoregressive models. We have three advantages for this vector autoregressive model. The first one is that the model is very simple, and there is no complication of endogenous and exogenous variable. We don't have to worry about the variable, whether it is a dependent and independent, because it treats all variables equally. And the second advantage of this model is that the estimation is simple. How it is simple? We can use ordinary least square method to estimate the model. Let us go back to our two equations. Here we have yt is equal to beta 1 minus beta 1 2 xt plus gamma 1 1 yt minus 1, and this whole equation. We can use OLS to estimate the first equation over here, and then again we use OLS to estimate the second equation over here, and we can easily obtain all these coefficients, the beta 1 0 beta 2 0. We can get these coefficients through ordinary least square. So the estimation of vector autoregressive model is very easy. Then these VAR models are better than more complex simultaneous equation model. This especially in reference to Mahmoud's paper which was published in 1984. It is very simple to estimate. There is no complexity, and its interpretation is somewhat better than using the simultaneous equations that makes it more complex. Then there are some disadvantages of the vector autoregressive model. That is that the VAR models are atheoretic. There is no theory backing vector autoregressive model. How? Because when we are trying to estimate a model, we usually have a relationship from a theory, that is that xt is causing yt, or yt is depending on certain variable xt, but we have a theory in its back. For example, the law of demand. Demand is caused by changes in prices. If prices increase, quantity demand will decrease. So we have a theory. So if we take yt as quantity demand and xt as the prices, we have a theory backing this model. But in vector autoregressive model, we do not necessarily have a theory on its backing. Yt cause xt, and xt can also cause yt. Both, there is a bidirectional relationship. Then there are lags. So interpreting these model is basically a bit difficult because of no theory on its backing. Then again, we have loss of degree of freedom. How do we face this problem? If you look at the models, we have over here a single variable. We have two variables yt, the second variable xt, but then we have lags yt minus 1 and xt minus 1. So these cause 2 degree of freedom, a loss of 2 degree of freedom. Now imagine that we have a variable that has lag of up to 12 lengths, yt minus 1, yt minus 2, yt minus 3, and up to yt minus 12. And then similarly we have a lag in this type of model that is up to xt minus 12. So how many degree of freedoms are we losing? We are losing 24 degrees of freedom in such types of models. So the model has a bit of disadvantage in this case. So we need to have a large data. If we have a bigger degree of freedom issue, the more legs we are taking, we need to have more observations to compensate for the degree of freedom. Then finally, another disadvantage of this model is the estimates are difficult to interpret. Why? This is again for the same reason that there is no theory behind the results. Yt is caused by xt, and xt is caused by yt. So how you interpret the reverse causality, that usually becomes a problem. And then again, not all of the variables may be causing each other, and we need to test them with causality test. And that is the topic for our next session, that we want to see whether there is a causation between the variables used in vector autoregressive model. Again, we need impulse response function to check the model. What is impulse response function? It actually we want to check the impact of a shock on the model, and this shock usually we are applying to the error term of the model and see how the model reacts to these shocks. So we will be studying impulse response functions in the coming lecture when we are estimating vector autoregressive model, and it is a very important part of the model. So hopefully you have learned a lot from this lecture, and we will continue with the vector autoregressive model. We will check the causality, and we will practically do it using eViews or Excel softwares to estimate the vector autoregressive models in the coming lectures. Thank you very much. Thank you for watching these videos.